Hi everyone, welcome to lesson 2 of trigonometry. Today's lesson is solving first and second degree trig equations. Before we get into the lesson, of course, we're going to start on our opener question. It says find the general solution for cosecant A plus 2 equals 0. So, what do? So in this first question here, what I want to do is isolate that trig equation. So I have CSE, cosecant A, and I'm going to move that 2 to the other side of the equal sign there, so this is now equal to cosecant A equals negative 2. From here, I'm going to rewrite cosecant as 1 over sine A equals negative 2. Isolating for sine A, we have sine A equals negative 1 half. From here, what I want to do is solve for A, but I also want to do a quick sketch here. I'm looking for two quadrants where sine is negative. So right away, I know that sine's going to be negative in quadrant 3, quadrant 4. So that's where my answer should be. Go into my calculator here. Sine inverse of negative 0.5. We get an angle of negative 30 degrees. So A here. So A is equal to negative 30 degrees. Therefore, our reference angle has to equal 30 degrees. And so 30 degrees will go right in here and right in here. So our two angles that we're looking for is, let's go in quadrant 3. We have an angle of 180 plus 30, which is 210 degrees, and in quadrant 4 we have an angle of 360 minus 30 this time, which is 330 degrees. And as this question didn't ask us to write it in degrees or radian, I'm going to do both. So of course this here is the same thing as saying 7 pi over 6, and 330 is 11 pi 6. There we go. So we have our solution. We're looking for the general solution, so let's write down our general solution. So let's do that right here. So in general, the first angle, A is equal to angle A, is equal to 210 degrees plus 360n, where n is an element of an integer. The second one we have, A is equal to 330 degrees plus 360n, where n again is an element of an integer. Of course, I can rewrite both of these in terms of radian, so let's quickly do that. So the first one here, 7 pi over 6 plus 2 pi n, where n is an element of an integer, and of course right under here, 11 pi over 6 plus 2 pi n, where n is an element of an integer again. There we have it, our answer in general solution. So, what do we do in this unit? Or sorry, this lesson. We're trying to solve for theta again, just like previous. This time it's going to take us a few extra steps to solve for theta though. So here we go. Solve the following algebraically. State your answer between 0 and 360 degrees. Round to the nearest tenth if necessary. So first things first, if I see a question like this, I want to combine all my trigonometry identities all to the same side. So I see 2 cos theta, I'm going to move it to the left, or from the left to the right. So I'm going to subtract 2 cos theta from both sides. Rewrite what I have. So right now I have 1 equals 3 cos theta. Let's isolate for cos theta by dividing both sides by 3. So really we have cos theta is equal to now 1/3. From here we want to evaluate this angle. We want to find theta here. So theta is equal to cos inverse, of course, of 1 over 3. And that's going to get us, let's go to our calculator, cos inverse of 1 over 3 gets us approximately 70.5. And of course that's in degrees. So if I have my first angle, what am I really looking for? I'm looking for two spots or two positions where cos is positive. So let's do our cast rule. Let's set that up, CAST. We know cos is positive in quadrant 1 and in quadrant 4. We know our angle was 70.5 degrees, so that means our reference angle is 70.5. So 70.5 goes right there, and theta right here, 70.5 as well. So we have our reference. So let's find our two answers. So in quadrant 1, our answer has to be 70.5 degrees, and in quadrant 4, that's just simply 360 minus 70.5, which gets us approximately 289.5 degrees. There we go. Solved for theta. In example B, we have square root 3 tan x plus 1. So what do we want to do? Again, we want to isolate for that tan x, so let's move everything away. So my first step, I'm going to move that 1 away and move it to from the left to the right. Gets us negative 1. Second, divide everything by root 3. There we go. Once I'm here, I don't really need to rationalize my denominator, but what I want to do is solve for x again. So x equals tan inverse of our negative 1 over root 3. So x is equal to, and again, let's go straight to our calculator. Tan inverse of negative 1 over root 3. And there we have it. Answer, negative 30 degrees. So, really, what are we looking for? Let's do a quick sketch. We're looking for two positions where tan was negative. That's going to be in quadrants 2 and 4. So let's draw a line from 2 to 4 there. So that's what we're looking at in quadrant 2 and quadrant 4. We know our reference angle here is 30 and 30. So let's do a quick note. So reference angle is equal to 30 degrees there. So in quadrant 2, our answer is going to be 180 minus 30, which is just 150 degrees. And in quadrant 4, it's going to be 360 minus 30. So this is quadrant 4, which is now just 330 degrees. And there you go. We have our two solutions. In example C, again, what I want to do here is try to isolate and have all my functions on one side. Well, right now I have sine x tan x equals 2 tan x. What I want to do is just move everything all to one side here, have all the trig functions all on one side. So I'm going to move my 2 tan x all to the left. So I have sine x tan x minus 2 minus 2 tan x. There we go. That's all equal to 0 on the right. Before we proceed any further, I'm going to draw your attention to this note over here. It says, note, do not cancel out trig functions that appear on both sides of the equation. You will lose answers if you do this. So if I had started off by canceling out tan x on both sides there, I wouldn't get the proper answer, and that's what I didn't do. So what I did was move all my trig functions all to the same side. Now that they're all on the same side, what I want to do is factor. So I'm going to factor out a tan x from both terms here. So this is a binomial factoring right now. So I'm going to factor out a tan x. So I have tan x bracket. Tan x times what gets you back to sine x tan x. So it's just a singular sine x. And then tan x times what gets you back to minus 2. And of course that's minus 2 tan x. And there we go. Equals 0. From here I can set each of my factors equal to 0 and solve for x. So I have tan x equals 0, and then I have on this side here sine x minus 2 equals 0, which I'm going to isolate for x, or for my trig function. So that's sine x equals 2. I'm going to finish off this side first, and here's what's going to happen. So if I go straight to my calculator here, and I go sine inverse of 2, let's see what happens. Oh, you get an error domain. So what does that mean? It means that sine x equals 2 cannot exist because remember our unit circle only goes as high as 1. We have a value of 2 here, and so that can't possibly exist. So I'm going to write down something along these lines. So unit circle has a radius of 1. And so therefore on this side here, therefore there's no solution. For any time we have a value bigger than 1 for our trig functions. Over here, 0 is definitely smaller than 1, so let's try to solve this. So I'm going to go tan inverse of 0. Let's see what happens here. Well, we get 0 degrees. Oh, interesting. So what does that mean? So let's do a quick sketch and see where that might fit in. So we have 1, 0, negative 1, 0, 0, 1, and 0, negative 1. And of course, here for tan x, what I'm looking at is sine divided by cos. So I need a coordinate here where I went y divided by x and I still get 0. Well, that's going to be here at 1, 0 and right here at negative 1, 0 because that's 0 divided by negative 1 and 0 divided by 1. So our answers for x here, so x is now going to equal 0 degrees, 180 degrees, and of course coming right back 360 degrees. There we go. And again, why do I have all three? Well, this is only the 3 that we need in our domain restriction. And again, our domain restriction was between 0 and 360 degrees. In example D here, we're going to do something very, very similar to example B or example C. So I have all my sine functions on one side, but what I want to do is try to solve for x here. So my suggestion would be to factor out a sine function. So what do we get? If you factored out a sine x from everything, you'd end up with sine x minus 3 equals 0. And from here, setting both of these factors equal to 0, you get sine x equals 0 and sine x minus 3 equals 0. And of course, this right side here, sine x equals positive 3. Therefore, right away, no solution. Reason being, same as over here. Your unit circle only has a radius of 1. That's 3 there, so you can't be on your unit circle. Here, when is sine equal to 0 ultimately, and that's what you're looking for, is when sine equals 0. Remember, sine is going to be your y coordinate in your ordered pair here. So sine x equals 0 at 0 degrees, at 180, and back at 360. So here, x is equal to 0 degrees, 180, and 360 degrees. There you go. In our next example here, it says solve the following algebraically, state the answer between 0 and 2 pi this time. So we're switching from degrees back into radian. But ultimately, you can work in any of the two modes, and as long as you have your answer in the proper notation, you should be fine. So in this one here, and what I mean by that is I'm working in degrees, and I'll eventually switch my answers back to radian. So for this first one here, let's isolate our secant theta. So secant theta is equal to 2 over root 3. Secant's the same thing as 1 over cos. So I'm going to quickly flip that around. So that's cos theta is equal to root 3 over 2. From here, what I want to find is theta. So again, going straight to my calculator, sine inverse of root 3 over 2. Or I could have used my unit circle, whatever's faster. I have 30 degrees. So theta equals cos inverse of root 3 over 2 there. We know theta is equal to 30 degrees, so therefore that's our reference angle. So let's find where cos is going to be positive. So I see that cos is positive in two quadrants. It's in quadrant 1 and 4. We already know the answer for 1. So in quadrant 1 it's going to be just 30 degrees, and in quadrant 4 it's 360 minus 30, which is 330 degrees. And mind you, this wasn't what we wanted for an answer. We wanted an answer in terms of radians, so let's convert. This is pi over 6 and 11 pi over 6. And so now our answer is in the proper units, or proper angle, actually. Over here in example D, this one here is slightly tricky. This one is cos squared x minus 2 cos x minus 3 equals 0. So what do we want to do here? Ultimately, this one's kind of tough to figure out. It doesn't look like anything that we've done so far. So what I'm going to do is I'm going to sub. Basically, I'm going to sub out cos x. So I'm going to write down a quick note, sub out, not sub in this time, sub out cos. So subbing out cos, I'm going to rewrite really quickly. And that gets me an equation of x squared, so no more cos there, so it's just x squared minus 2x minus 3 equals 0. Maybe we can solve this one a bit better. Well, from here, your options to solve this would be to factor, would be to use quadratic formula, or would be to use your graphing calculator. I'm going to do a quick factor. So here, if I factor this, I get x minus 3 and x plus 1 equals 0. So now that I'm down to my factors, I'm going to sub in cos again. So sub in cos. So this is going to be rewritten as cos x minus 3 cos x plus 1, and all of that's equal to 0. Let's set each factor equal to 0 now. So this one on the left we have is cos x minus 3 equals 0. So we have cos x equals positive 3. Therefore, no solution because we're not on our unit circle. Okay. On the right side, our factor here we have is cos x plus 1 equals 0. So that's cos x equals negative 1. And of course, cos is equal to negative 1 in only one position. That's at our 180 degrees or at pi. And I'm going to just write x equals pi. Because that's where, because our domain is between 0 and 2 pi, that's the only position where cos is equal to negative 1. So therefore, that's our only solution. We have one more here for part question 2. So again, what am I doing here? I got 2 sine squared x plus 7 sine x minus 4 equals 0. So what do I want to do? I'm going to do a sub out. Rewrite that in terms of all x's. So I'm going to go 2x squared plus 7x minus 4 equals 0. And again, you have options of solving this. You can either factor, you can use quadratic formula, you can use your graphing calculator. Any of the three options work. I'm just going to quickly use any of them, and if I use my graphing calculator this time per se, I have x equals negative 4 and x equals positive 1/2. If I have that, I'm going to sub back in the word sine, so I have sine x equals negative 4 and sine x equals 1/2. Of course, over here, that's a no solution situation. So no solution there on the left. Here, sine x is equal to half where? Well, we've got two sections. sine x equals positive 1/2 in quadrant 1 and in quadrant 2. So let's first find x. So x is equal to 30 degrees, of course, because we went sine inverse of 1/2, 30 degrees. So in quadrant 1, I know my answer is going to be 30 degrees. Quadrant 2, we're going to go 180 minus 30 equals 150 degrees, and of course we want both of these in terms of radian, so let's switch it over. That's pi over 6 and 5 pi over 6. And there we go.